When we think of clean energy, we often picture a bright, sustainable future powered by electric vehicles, solar panels, and wind turbines. But what if I told you that the path to this greener tomorrow is paved with some unsettling truths? Welcome to our channel, where today we uncover the dirty side of clean energy: lithium mining and EV battery production. As the demand for electric vehicles skyrockets, so does the need for lithium, a key component in the batteries that power them. But this rush for green energy comes at a significant cost. From environmental degradation and water shortages to human rights abuses in mining communities, the true impact of lithium extraction is often hidden beneath the surface. We'll dive into the complex issues surrounding lithium mining and battery production. We'll explore the environmental footprint of these processes, hear firsthand stories from communities impacted by mining operations, and discuss the critical question: is the push for clean energy worth the dirty side effects? Let's take a closer look at the intersection of sustainability and social responsibility, and uncover the realities behind the technology shaping our planet's future. Let's get started. Extracting just 1 ton of lithium requires an astounding 500,000 liters of water, which can even threaten existing water reserves. This is just one of the many challenges and hidden environmental costs associated with the rapidly growing demand for lithium in electric vehicles. Clean energy sources such as wind, solar, and hydropower are often heralded as the solution to climate change and the key to a sustainable future. In recent years, electric vehicles have emerged as a poster child for green technology, promising to revolutionize transportation while drastically reducing carbon emissions. Consumers and governments have embraced the notion that EVs are an eco-friendly alternative to traditional gasoline-powered vehicles, with many countries even offering incentives to encourage their adoption. As a result, global EV sales have skyrocketed, and major automakers are racing to expand their electric offerings. However, the reality of EV battery production is far from clean. Lithium, a crucial component of EV batteries, requires extensive mining operations that can have significant environmental impacts, often hidden from the public eye. The transition to renewable energy sources is a key component in the global effort to combat climate change and reduce our reliance on fossil fuels. Electric vehicles have emerged as a critical tool in this shift, as they offer a viable alternative to internal combustion engine vehicles, which account for a substantial portion of greenhouse gas emissions. Governments worldwide are implementing policies and setting ambitious targets to phase out gasoline-powered vehicles and promote the widespread adoption of EVs. By harnessing clean electricity from renewable sources like wind and solar, EVs can help decarbonize the transportation sector and contribute to a more sustainable future. Moreover, the potential benefits of EVs extend beyond their direct environmental impact. As battery technology continues to improve, EVs could enable more efficient energy storage, allowing renewable energy sources to be integrated more seamlessly into the power grid and enhancing overall energy security. However, it's essential to acknowledge that the environmental benefits of EVs are only realized when the entire life cycle is considered, including the extraction and processing of raw materials for battery production. Lithium, a soft silvery white metal, has emerged as a critical component in the energy transition, particularly in the production of electric vehicle batteries. Its exceptional properties such as high energy density and lightweight nature make it an ideal choice for powering EVs. Lithium-ion batteries, which rely on lithium as a key ingredient, are the most common type of battery used in EVs today. They offer several advantages over traditional batteries, including longer lifespan, faster charging times, and higher energy storage capacity. The growing popularity of EVs has driven a significant increase in demand for lithium, with experts projecting that demand for the metal will more than double by 2025. This demand has placed a spotlight on lithium mining and production, as well as the challenges and environmental costs associated with extracting and processing this valuable resource. There are 2 primary methods for extracting lithium from the earth: brine extraction and hard rock mining. Each method comes with its own set of challenges and environmental impacts. Brine extraction involves pumping lithium-rich brine from underground salt flats, typically found in arid regions such as South America's Lithium Triangle and China. The brine is then left to evaporate in large ponds, allowing lithium salts to crystallize and be collected. Raw materials and finished batteries must be transported across long distances, contributing to greenhouse gas emissions. While batteries can be recycled, the recycling process is also energy-intensive and does not recover all materials efficiently, resulting in additional environmental costs. Waste management is another significant challenge associated with lithium-ion battery production and use. Lithium-ion batteries contain toxic materials that require specialized handling and disposal to prevent contamination of the environment and harm to human health. If batteries are not properly recycled, they can end up in landfills, where they pose risks of leaching harmful chemicals into groundwater and soil. While lithium batteries can be recycled, the process is complex and costly, making it less attractive to businesses and consumers. Not to mention that the infrastructure for recycling lithium-ion batteries is currently limited, particularly in developing countries, which leads to challenges in effectively managing battery waste. While noble in its intent to combat climate change and reduce dependence on fossil fuels, the pursuit of clean energy can inadvertently perpetuate exploitation. The production of clean energy technologies like lithium-ion batteries requires the extraction of raw materials, such as lithium, cobalt, and nickel. These extraction processes lead to environmental degradation, including water and air pollution, habitat destruction, and carbon emissions. Mining operations can also have significant social and labor implications, particularly in developing countries, with weaker regulations and oversight. This can include labor abuses, exploitation of local communities, and displacement of indigenous populations. The disposal and recycling of clean energy technologies such as solar panels and batteries can create new waste management challenges, potentially leading to pollution and environmental degradation if not properly managed. While the production of lithium-ion batteries and electric vehicles presents various environmental challenges, promising innovations are emerging in lithium extraction and battery recycling that could help mitigate these concerns. Some companies are implementing more sustainable mining practices, such as using renewable energy sources to power operations, reducing water usage, and engaging with local communities to minimize social and environmental impacts. Several emerging technologies aim to improve the efficiency and effectiveness of battery recycling. These include hydrometallurgical processes, which use chemical solutions to separate valuable materials from batteries, and direct recycling techniques, which aim to recover lithium and other materials with minimal processing. Some companies are exploring circular economy models for EV batteries, such as reusing spent batteries in energy storage applications or designing batteries to be more easily disassembled and recycled. In addition to lithium extraction and recycling innovations, researchers and companies are also exploring alternative battery technologies that offer improved performance, safety, and sustainability compared to conventional lithium-ion batteries. Solid-state batteries use a solid electrolyte rather than a liquid or gel, which can improve energy density, safety, and lifespan compared to lithium batteries. Several companies, including Toyota and Samsung, are investing in solid-state battery research and development. Also, sodium-ion batteries offer a potentially more sustainable alternative to lithium-ion batteries, as sodium is more abundant and widely distributed than lithium. Sodium-ion batteries could also be less expensive and safer than lithium-ion batteries, though they currently have lower energy density. While these alternative battery technologies are still in various stages of research and development, they offer promising opportunities to address some of the limitations and challenges associated with lithium-ion batteries. It is essential to look beyond the use phase of clean energy technologies and consider their environmental impacts throughout their entire life cycle, including raw material extraction, production, transportation, and end-of-life management. While electric vehicles are good, you must be aware of greenwashing, where companies exaggerate or misrepresent the environmental benefits of their products. It's important to seek out credible information and be skeptical of claims that seem too good to be true. We want to hear your thoughts on this topic, so leave us a comment. Remember to like, share, and subscribe to this channel for more videos like this, where we discuss EVs, tech, and innovation. Until our next video, thanks for watching.